right, guys, my favorite topic, routing and switching. So I already explained to you guys how it's going to go. We're going to do the path of packet at each device, right? The source, right, is, and just to give you the lay of the land of the scenario, we have PC1 that's trying to get an IP address, right, from the Windows server that's on the top right, okay? Because it does not have an IP address, right? We see this scenario every day whenever you plug in your computer into your docking station, or you connect to the Wi-Fi, what have you. It goes through the DOR process within DHCP, right, to go ahead and get a IP address, right? Sometimes, right, certain topologies, certain deployments, it has to traverse layer 3 boundaries, okay? And so that is a perfect way to go ahead and try to understand layer routing and switching, right? Is to understand the process of package traversing layer 2 and layer 3, getting to that destination, which of course is the DHCP server, and traversing back. Okay, so I'm going to ask you guys questions right at each hop, right? What the packet, right, is supposed to look at each device. Okay. All right. The only thing I expect from you guys, if you guys don't know something, it's perfectly fine to say I don't know. If you guys don't know, we're gonna go ahead and I'll go ahead and give you guys the course correction. And then Wednesday and Thursday, we'll go over routing and switching, right? And come Saturday, we'll go ahead and revisit a topology similar to this. And we go ahead, and I expect you guys to go ahead and be able to give me the path of the packet the correct way after we're done. Okay?
Yep.
All right. So let me go ahead. Let me just make one change. Let me call this the DHCP. There we go. All right. So we're good. Call it DHCP server. So what I'm going to do, I'm going to go ahead and create this so we can go ahead and keep track. All right. So we're going to put source MAC, right? Because that's going to be in a packet. We're going to put destination MAC. We're going to be source IP, right? And we are going to put destination IP. Okay. All right. So I'm going to flip, right, between the both of you guys of asking questions. Okay. So let's go ahead and get started. So we're at PC1, right? I plug in my laptop, right? I plug in my laptop. I need to get an IP address, right? To, it needs to reach the destination of the DHCP server, right? But I don't have an IP address just yet, right? So based on, and every device has a MAC address and they have an IP address. So if you guys can't see it, let me know. But just take your time on answering. I don't want you guys to answer quick. So Mike Evie, as far as the source MAC, right? What will be the source MAC be of the packet leaving PC1?
It'll be AA.
Okay. Well, uh-oh, 1 second. What's going on? There we go. All right. AA. Get up. All right, extend this. All right. Done. Destination MAC. And mind you, reminder, this PC is trying to get an IP address, right? So what is a destination MAC?
EE.
EE. Okay. Gotcha. What is the source IP address? Mike Evia.
We'll be sourcing an IP for the switch of AB, so it'll be 192.168.1.10.
Okay. Don, what is our destination IP address?
We'll be trying to get to the DHCP server, so
Mhm.
172.16.1.25.
Okay. Okay. This is a start. This is a start. This is good. So the only correct thing, right, that we put on here is the source MAC.
Oh, for real?
Okay.
Wow.
Yeah.
Okay.
It's guys, it's okay. It's okay. It's all right. Right. So and I want you guys to we're gonna get used to this, right? So as far as the destination MAC, right? We don't know about the other network, the other private network, right? We don't have that information because we just plugged our PC in, right? Can you guys agree?
All right.
Yeah.
Have a source IP. We're trying to look for one.
Exactly, right?
Oh,
So it has to go through the DHCP process first, okay?
oh,
All right. And so what that destination MAC is going to be, right? Because it's trying to look, right? It's yelling, who is my DHCP server? So whenever we do a broadcast message in switching and routing, right? That destination MAC address is going to be all Fs. Okay. Let's go ahead and move the source IP, right? So source IP, right? This request is not coming from switch one. So we can't put the source to be .10, right? And so even though it has an IP address, it's doing layer 2 functions for this topology. We just have an IP address just so we can reach it and manage it. Its core function is layer 2, which is switching, okay? And
oh,
so, right? And so the source is PC1. And I told you guys it doesn't have an IP address. So what that source IP is going to be,
oh.
0. Okay. Doesn't have one yet.
it doesn't have one yet. Okay. Now, Don, you were on to something. You were wrong, but you were on to something, right? That tells me you're looking in the right direction. But PC1 doesn't know about that server just yet because it just plugged into the network. Okay.
Okay. So it only knows about
So
the switch now, right?
it knows about the switch from a layer 2 perspective, right? And I'm going to get here, but it's doing a broadcast, right? To try to figure out where is the DHCP server. So from a layer 3 perspective, how a broadcast looks like is this.
Mm-hmm. Okay.
Okay.
Okay. So the device, the PC is communicating at layer 2, just based on the MAC of the hops.
The switch, right? The switch is
Oh,
performing those layer 2 functions, right? The PC1, right? It's doing layer 2 and layer 3. It's a host, right? It's a PC, right? But it just can't communicate anywhere outside of its private network.
oh, right. So that's what the switch is for. Okay, got it.
Okay. All right. And so essentially, yes, right? The switch one can respond to this DHCP request, right? But it's not, right? We didn't configure it as such, right? So it's going to go to all hosts within the network, within the broadcast domain. Let me get my pencil, right? It's gonna send this message, right? That broadcast, all right here. That's it. It's not going to leave the network. That broadcast is going to stay within that local area network right here because it's going to send that broadcast within the broadcast domain. Okay.
Okay.
All right. So switch one's going to get it, right? It's going to go ahead and receive it. It's going to say, oh, I received a broadcast message. I need to forward it out of all ports. And you guys will learn this when I go over switching, except for the port that I received it on. Okay. And so Now that it received it on all the ports that it's going to shoot out the broadcast message out of all of its ports that it received it on, except for the port that it received it on. The next port that's available is going to receive it on is R1, gigabit 0/1. Okay. Within routing and switching, they have this feature called DHCP relay, right? Similar to a relay race, it's going to be a handoff, right? A handoff of what? Of a DHCP, right? So DHCP requests start off as a packet that doesn't have an IP address, right? It has a unknown destination IP. Okay, that's how it starts off. But we need to go ahead and reach that DHCP server, right? That's right here. But from what I told you guys, those broadcast message doesn't leave this broadcast domain. So we need to do some routing and switching, right? To make sure that it can traverse, right, a public network, get over here and go ahead and reach the DHCP server, and we can go ahead and it can come back. So, right, and I'm going to repeat that again, so it can leave and come back to, right, the source, the true source, so that we can go ahead and get an IP address and start doing our work for today's job. That makes sense?
Yes.
Kinda.
Okay, well, we're getting
I'm
to
following.
it. Okay, so with DHCP relay, that relay functionality is on the router. And what that router is doing is it is receiving this broadcast message and saying, hey, I'll go ahead and take care of this for you, similar to the USPS mail service. I'll go ahead and take this piece of mail for you, and I'm going to deliver this letter to your grandma, right? Because you can't drive all the way to California to deliver it to her. You can, but I'm going to go ahead and do the handoff here. Okay? So it's going to go ahead and receive that. What this router is going to do, it's going to receive this packet. It's going to say, oh, right? Within the packet details, this is a DHCP request. I'm going to do my function and let you know what the IP, and Don, this is why I said you were cooking with grease a little bit. I'm going to let you know what the DHCP server, where that DHCP server is.
Okay, I'm following.
Okay. All right. And so what R1 is going to do with one of its functionalities within the DHCP relay, it's going to respond back, right? It's going to respond back from a layer 2 perspective and let PC1 know, right? Because we don't have to worry about layer 3, right? So we can actually leave these blanks. It's going to respond back and say, hey,
The MAC address.
right? Right? But the additional part is going to be, okay? So it's going to send that back to PC1, right? It's going to send it via layer 2. It's not sending it via layer 3. We don't have no IP addresses. It's going to send it back, right? And say, hey, you're trying to get an IP address from the DHCP server. That's your true destination. Okay?
Okay, I see.
So let's go ahead and erase this. So now PC1's going to have it. It's going to say, oh, thanks for letting me know. It's going to go ahead, right? Do the same thing that you and Makivia just said, right? Our destination, right, is going to be R1.
DB. Okay.
Our source IP going to be 0.0.0.0 because a fact is a fact. We don't have an IP address just yet. But the destination is that DHCP server. Okay. All right. You
Yeah, so it
following?
really doesn't know what it is until it gets to R1 pretty much, where it has to go like the actual destination to its first router, right?
Exactly. Right.
Okay.
So stay with me here. So this destination that IP that I put here, this is just logically. Whenever you guys look into a packet, here's what it's going to say. You ready?
Why? Why does it have the 192.168.1?
Ah, okay. So
Okay, router one.
Oh, because that's router one destination. That's the IP address for router one. Because that's a
that's
destination that it knows about.
that's part of it.
Okay.
Remember, I told you guys, right? If something leaves the network, it needs a way to come back. If we leave the source, and I'm gonna get to it. If we leave the source to be 0.0.0.0, we have the destination IP, right? If we left it where it said 172.16.1.25, router one knows how to get to the 172 network. The DHCP server is going to receive the request, and it's going to have a destination of 0.0.0.0. Where's it going to send that to?
Is it sending it to switch 2 or switch 3? Or
It will.
router?
It will. But within routing and switching, a 0.0.0 address is an unknown host.
Right, it's a broadcast.
So it's not so much a broadcast. 0.0.0.0 is just an unknown host.
Uh-huh.
So it's not going to know where to send it. So it's what DHCP server is going to do is just going to send it into the wind, right? Until it's switched, and it's not going to be delivered, right? And let me tell you guys the reason why. So one of the rules within routing, right? Routing and switching is that broadcasts, right? I'll help you with this, right? I'll let you guys know broadcast messages stay within a broadcast domain, right? Broadcast domain is another name for a local area network, okay? So broadcast messages, here's a rule now, cannot traverse layer 3. Okay?
Right, because it's just ARP request, right? Is that what?
Not so much, right? Not so much. Just keep this in your head. Broadcast messages at its core cannot traverse, right? Cannot traverse over layer 3. It cannot. And in the days coming, I'll explain why. Okay? Broadcast messages cannot traverse layer 3. And what a DHCP message is, it's a broadcast message. Okay? A flavor of it. Right? So broadcast messages, right? If they can't traverse layer 3, that means the DHCP server is going to send that message, and of course it can't leave here. Then it's going to be dropped right here. Because R2 doesn't know what a 0.0.0.0 address is. Make sense?
Right.
Okay.
Kinda. I'm just trying to see how it's gonna get its address now.
You're good. You're good. You're good. So, and this is a feature within DHCP Relay, and you guys don't need to remember this for routing and switching, but you guys do need to know this for this exercise so you can understand routing and switching. Okay. So what R1 is going to do with the DHCP Relay feature enabled, it's going to say, excellent, right? I got this DHCP request from them. Now, what I'm going to do is manipulate it, right? Manipulate this packet to where I'm going to rewrite the packet, right? And the reason being is that if I'm going to send this request out to the DHCP server, it needs a way to get back to this network, right? As soon as it gets back, from a layer 2 perspective, I can go ahead and send this back to PC1. Okay? From a layer 3 perspective, I cannot. but a layer 2 I can. So what I'm going to do, right, is I'm going to encompass this original request. We're going to set this right here, right, because that's the original request. And we're going to rewrite the request and put it right here on R1 because we're going to leave the network. And here's how the packet's going to look now. I'm hoping for oohs and ahs a little bit. Questions?
I think I'm starting to see what's going on. It's gonna make its way. It's just gonna make its way there till we can actually get out of that layer 3 zone to get the IP address.
Close.
Okay.
Close. You're getting it. You're getting it. Right. So this is right. This is what I grabbed. This is encapsulated within this new packet. Okay.
Oh my God. Okay. Jesus
Okay.
Christ.
Okay.
Okay.
But this is now the new header because we need this packet to come back from a routing switching perspective. Because like I said, a 0.0.0.0 is an unknown host. It
I
can
see
reach the
now.
DHCP server from a routing and switching perspective. It will not know where to send it back to. You understand?
Now it does.
Okay.
Has an IP address.
So let's take a step back, right? And let's start at the source MAC. The MAC address changed, right? At the source and destination. One critical rule I want you guys to understand, right? The same rule with the layer 3 boundaries, right? That applies to broadcast. It also applies to MAC addresses. Okay? Whenever you cross a layer 3 boundary, the core rule is, right? This is just a special case. The core rule is that the source IP, right, and the destination IP will never change. That within a packet will never change. Natting and stuff like that you guys learned about, that's different. But at its core, a source and destination IP address will never change. Okay? You guys with me?
Yep.
You guys with me? But
Yep.
a source and destination MAC address, whenever it crosses a layer 3 boundary, it will always change.
Okay. That makes sense.
Okay? So let's say switch 1 wanted to communicate with the DHCP server, right? It has an IP address. As soon as it leaves R1, R1 gets the packet, and R1's going to forward it to its destination. The new source MAC address is going to be R1. And it's going to go ahead and send it to R2, right? Because that packet traversing the wire, it's going to go ahead first, when it's encapsulated, it's going to be encapsulated all the way down to layer 1, going to traverse the wire, get to R2. R2 is going to get it, and it's going to de-encapsulate it. Just like how, if we're talking about the USPS Postal Service, right? We're talking about her grandma receiving the letter, right? The USP, she hasn't got it yet, but the USPS is going to see the letter, and they're going to say, all right, I got the physical, right? Which of course is layer 1, right? I got the physical, right? But let me go ahead and look at the, where it's coming from and where it's going to, right? So the mail worker is looking at this and saying, I have where Donovan lives and I have where his grandmother lives, right? And that is what R2 is doing. It's looking, right? It's looking at the source MAC, destination MAC, source IP, destination IP. It's looking at all that information. It's going to say, excellent, right? I'm going to go ahead and I know how to send this to California. it's going to go ahead and put it in the to California box, right? And that's essentially what a router is going to do, right? The router is going to go ahead and it's going to go ahead and R1 is say, hey, here's the source MAC, right? Here's the destination MAC. But the reason why it knows how to change the destination MAC, right? Because it's on the same broadcast domain, it's going to look at its routing table and it's going to say, how do I know how to get to the 172.16 network? Okay, I have an entry in my routing table that says, for me to get to 172.16, I need to forward it to router 2. And how I get to router 2 is this specific IP address, which of course you guys can see, 6. Let me go ahead and get my pencil. I know there's a lot here. Is 6.4.2.2. That's the next hop, right? Dot 2 is the next hop. That's R2, right? So pulling back the ARP thing, right? Pulling back the ARP thing from my Kivia, right? R1 is going to say, excellent, right? I know where to send this packet. Let me do an ARP request first. Hey, where's 6.4.2.2, right? R2 is going to respond, hey, 6.4.2.2 is this at layer 2. I mean, this at layer 3, but here's layer 2 information. So you can go ahead and you know where to send this. Okay? So the destination isn't going to change. The destination IP address is not going to change. But the destination MAC address needs to change.
Changes. Okay, I'm following.
The reason being is because it needs to send it, right? It needs to send it out the right interface, right? And it's going to send it via layer 1, and it's going to be de-encapsulated to layer 2, then to layer 3. But we need to see layer 2 first. You understand?
Yes.
So it's going to go ahead and send it to R2. R2 is going to get it, and it's going to look like this, right? So now we're at R2, right? R2 gets it and say, all right, buddy, cool. So now you're trying to get to .25. So now if I want to forward it to 25, you're crossing another layer 3 boundary, right? You're going from the public network to the private network. So now the source again is going to be CC, and that, hold on, and that destination is going to be what? The destination MAC address of the DHCP server, which is EE, right? Okay. Source doesn't change. Source IP doesn't change. Destination doesn't change, right? But how does R2 know the destination MAC address of EE? I mean, destination MAC address of the DHCP server, right? Reeling back in what Mikey just said about the ARP request, right? So let's go ahead and get my favorite pencil, right? So we spoke about the broadcast domain that's right here, right? This is also a broadcast domain. Oh, funny enough, this is also a broadcast domain. Okay? So that ARP request, right, is sent out of R2's interface that's facing the private network of 172.16. So it sends out, it says, okay, I know about my network. I have that in my routing table, but who is .25? It's going to send that ARP request and say, hey, who is .25? Tell me your MAC address, right? The DHCP server is going to respond back, and it's going to say, oh, I'm .25. Here's my MAC address. Bet. I have it. I have your MAC address. I'm going to forward this packet that's destined for you, right? So it's going to be sent onto the wire, but we have a lot of switches here, right? What path is it going to take, right? So now we step into the realm of spanning tree, right? So what is spanning tree and what is its goal, right? So spanning tree, right, is a loop prevention technology, right, that is one of the core functions of a switch, right? And its responsibility is to prevent loops, right, within a layer 2 topology, right, on redundant links, right? So if we look at, right, if we look at this baseball field, right, we're going to call it, right, of switches, right? Everything is connected to everything. So we have redundant links, right? So if switch 6 goes down, we can still reach switch 4 through switch 5 or switch 3. Switch 5 goes down, we can reach switch 4 through switch 6 to switch 3. You understand? Right? But, right, if spanning tree did not exist, and this is just a spoiler, right? We'll go over this tomorrow. If it didn't exist, right, R2 sends that ARP or just sends a message in general, it's going to be received on switch 2, right? And switch 2 not knowing where to send something, it's going to send it as a broadcast. So with broadcast, it's going to send it out of, like I told you guys before, out of all ports except for the one it received on, right? So switch 2 is going to do its job and forward that broadcast out of all ports. But then switch 5 is going to do the same thing. Switch 6 is going to do the same thing. Switch 3 is going to do the same thing. Switch 4 is going to do the same thing. So now we have all these broadcasts going together, right? They're all forwarding out of all of its interfaces. And guess what we have, ladies and gentlemen? We would have, if spanning tree wasn't implemented, we would have a broadcast store.
I can see how that would be a storm.
AKA a loop. Okay. So then the packet doesn't even reach the DHCP server, and now things are broken. So spanning trees is in place to prevent that, so that, stay with me, and this is the important part, so that there is one path to each part of a network. There's one way in, there's one way out, right? And I'll go into details about how that works, right? But we're not going to go into details tonight, okay? So R2 sends it to switch 2, right? Let's say spanning tree is populated properly, right? It's going to go ahead and send it, keep it simple, send it to switch 3, send it to the DHCP server, right? The DHCP server gets it. It says, okay. So you're trying to request an IP address. Bet. So here's what I'm going to do. I'm going to respond to that. I'm going to make the source MAC address this, right? Now, Don, what is my destination MAC address from the DHCP server's point of view?
From the DHCP server point of view?
Now, if it's sending it back to PC1, because now that it reaches destination, the roles has reversed. So now if it's responding back to that original packet, what's going to happen?
It's going to, well, the IP address is going to stay the same. The MAC's just going to change. So it's going to be DG. Would it be DG?
It will
Oh,
not.
no, it will not.
Nope.
It can't
that
be AA
MAC,
because it doesn't know where to go, right?
Yep. But remember what I said. It can communicate with all hosts within its same broadcast domain, aka its local area network. So it's going to send it back. It's going to send it back to this.
Oh, because it's in the okay.
Right?
Okay.
Because in the DHCP server's routing table, right? It doesn't know about the 192 network. It doesn't know. It doesn't really care. All it has is a default gateway of 172.16.1.1, which is R2.
So it only really goes to those switches one time to get there, and then when it gets there, it's gonna go straight to the router.
Yep, because here's the thing, right? At layer 2, a packet, right? But at layer 2, a packet is not called a packet; it's called a frame because it's at layer 2. But sorry about that, guys. this off. 1 second. Sorry about that. So from okay, I'm breaking things. From a layer 2 perspective, right? It will never change. Okay? Switches will never change the source and the destination of an actual frame, right? If we're talking about a packet, it will never change the source and MAC address of a packet. Switches will never do that. Their other two core functions is to, one, learn MAC addresses based on where it received it on, right? And two, it's going to go ahead and learn, right? It's going to go ahead and learn, but it's also going to forward or filter, meaning, of course, discard, right? MAC addresses, right? And those frames that are received out its respective ports, but it will never change the source and destination MAC address. You understand? All it will do is forward it, okay? That's all it will do. That's all it will do. It will just forward it. So the DHCP server is going to send it down to switch 3. Oh, cool. We got to get it to EE or CC. Cool. I know where to forward that. That's it.
Okay, I see. I'm following you now.
That's it. But
it's starting to make sense.
Yeah. Okay. So the source IP now, my key is what?
Sorry.
You're
You
good.
asked about the source IP?
The source IP now with the packet coming from the DHCP server. What's the source IP now?
You're sourcing from, would it be the DHCP server?
Mm-hmm. And what's that IP address?
172.16.1.25.
There we go. Now what's the destination IP?
The destination IP would be, want to go to C.
190.
Oh no, go ahead.
No, you go. I might be wrong.
Well, if you're going to the MAC of CC, then it would be, would it be the
6.
I'm not sure if it would be the 172.16. No, that's the same. So it'd be 6.4.2.0 or .2, or is it the 172.16.1.1 on the other side?
It's okay. It's all right. So remember the core rule, right? We're trying to get back to the other private network.
Like
right?
what it is?
Right? We're trying to get back to the other private network. So, right, we changed that how the packet looked, right? And the source, whenever we sent it to the DHCP server, was 192.161.1.1, which is the inside interface of R1.
Wow, we just switched.
Yep. Because now,
oh my God.
Now the DHCP server is the source, and PC1 is the destination now, because it received its request. So now it's going to go ahead and send it back. So, oh, cool. I'm going to send it back to how the packet looked like when I received it. It doesn't know about this right here, but it knows about this. So when it was received, that source was 192.168.1.1.
I see.
Make sense?
Yeah. I was going to say that. I wasn't confident though. Damn.
It's okay. It's okay. So in efforts to send it back, the DHCP server is going to say, hey, I responded to the DHCP request. I don't know where 192.168.1.1 network is. I'm going to look into my routing table, because every device has a routing table. It's going to say, I only know about my default gateway, right? So I'm going to forward this damn packet to my router, right? My default gateway, .1. I'm going to send it there. But I'm not going to change the destination IP. I'm just going to change the destination MAC because I'm going to do a ARP request of, right, of the router, and I know the MAC address is CC. So I'm going to go ahead and send it to my default gateway, right, and send it here. Boom. So R2 is going to get it, and we're going to go ahead and change that MAC address again. So now the source, right, because it's crossing layer 3 boundary, is CC, and I need to send it back to R1. So, my Kevia, what's this MAC address? The destination MAC address from R2's perspective, trying to forward it to R1.
R2 to R1.
What's the destination MAC?
Would it be BB?
There we go. Right? Right? So it's BB. We're still not changing the source IP and the destination IP. We're not doing that just yet. Okay? So now we're routing and switching, sending it to here, right? And so now we got it here, right? The DHCP relay function, right, has worked properly. It's back in the network. So now what R1 does is, all right, let me take off the DHCP relay header, right? And I got the packet back. How this packet is going to look now is this. Here's the source MAC. That destination is PC1, right? The source, right, is 168.1.1. Destination, I'm sorry, made a mistake. A second. That source is 172.16.1.25. Destination is 0.0.0.0, right? And of course, within the DHCP details, it's going to have, you know, of course, the offer, what have you. But it's going to know to send. It doesn't know where the destination IP is at, but it's going to forward it to AA, which is the PC1. PC1's going to get it. It's going to see the offer of an IP address. Then it's going to keep flowing back and forth until the DORA process is complete. Right? It does all its routing and switching. And then you'll finally have an IP address of, we'll give it some random one. 192.168. Whoopsies. Hold on. There we go. 192.168.1.50. Right? Now it has the IP address. And now the path of the packet is complete.
I
Any
did not
questions?
know all of that is entailed in it. Oh my God.
Whenever you go to Google, whenever you go to, yeah, right? And we talked about the packet rewrite, right? Right? Even with the DHCP relay, it's rewritten even further if we're using, because you guys learned about NAT, it's rewritten even further. Right? So it's not more so rewritten, it's an additional header of a source, right? MAC and source IP and destination MAC and destination IP, right? And so it'll leave R1, right? And this is just a spoiler alert, right? It's that source is going to be, right? If we're using NAT, right? Destination is going to be, right? Right? Because it knows where to send it to, right? It knows to go ahead and send it to that because R1 knows about that, right? But this is in-depth stuff about routing and switching that you guys will learn, that I will attempt to cover this week, right? And that's the additional header that's on top of, right? That's on top of this, that's also on top of this, how the original packet looked like. Oh. Yeah, boo-boo. There we go. There we go. Right? So it's many things that are happening in the background, right? Our firewalls are doing it. Our access points are doing it. Yeah. Oh, yeah. Any questions?
No, this was great though.
Oh yeah. Oh yeah. Oh yeah. All right, guys. Well, I know this is a lot. I'll put the recording on. Please watch this again. And tomorrow we're going to cover as much as we can about switching. Okay. Thursday will be routing, and then we're going to do this exercise again on Saturday. Okay.
Already sounds good.
All
Sounds
right,
good.
guys. All right, guys. You have a good day.
All right, thanks. Take care, guys. Bye.
Bye.